Okay, hi guys. I am back making videos for our notes. This will just be a quick one. Again, we're going to go on with area. On Monday, we did area of trapezoids, triangles, parallelograms, and like rectangles and squares. A lot of that stuff I would assume we have seen before. Today we're going to keep doing area, but we are going to do area of circles, circle sectors, which we'll talk about, kites, and rhombuses. Okay, I have all of those formulas given to you, and I put them on a PDF that I shared with you. Okay, it's called Day 2 Area Formulas Cheat Sheet. All right, and I'll show it to you here. I'm just going to go through one example of each of those 4 shapes, and then we will be done and you can do your homework. So I'm going to share my screen here. Desktop. Okay. All right, so on here I have formulas over here. For me, they're on the left. Okay, Day 2 area formula cheat sheet. Number 1, area of a circle. And then over here I have the problems we're going to work through. Okay, so on number 1, we have a circle. All right, let's see, we have right here, we have a circle. It has a line going all the way through it. Remember, if it goes all the way through the middle, that's a diameter. I know from my formula over here that the area of a circle is pi times radius squared. So I want to find the area. So I'm going to take pi times the radius squared. Now, just a reminder, a lot of us probably know this, if my diameter is 10, radius is half of that, so my radius would be 5. Okay, so I'm going to take pi times 5 squared. And then you could just do that in your calculator. Our area equals pi. I'm just going to use the pi symbol on my calculator, times r squared, or 5 squared, which is 25. Pi times 25 is 78.5. And remember, with area, we always do the unit. So this one is centimeters squared. All right. And that is how we do area of a circle. So next on here, I'm going to clear this so I can scroll down a little bit. So hopefully you got that. Next, this is area of a circle sector, okay? Basically what that means is that we just want a section of the circle. So I want to find the area of this shaded in part right here. That's in orange. And I'm outlining it in red. So I just want the area of this part right here. Okay, this is actually a super similar formula to our arc length. Okay, and okay, what was I trying to do? I was just trying to show you this over here. So right here is area of a circle sector. Okay, how we're going to do that is we have to take pi r squared, that's the area of a circle, pi r squared, times the central angle. That's just the degrees of the angle. So like on this problem over here, it takes me forever to write on here, degrees, okay, divided by 360. So I'm going to do that over here. So our area formula is area equals pi times r squared times my angle divided by 360. Okay, so area equals pi times r squared. I can see on here that my radius is 4. So 4 squared times my angle, which is 120, divided by 360. Okay, from here, it's just plugging stuff in. So I'm just going to use my calculator. Okay, I'm going to take pi times 4 squared, which is 16. And then I'm going to multiply. I'm going to put this in parentheses. Okay, I'm going to multiply by parenthesis 120 divided by 360. My final answer, I get, oops, I meant to make that capital, 16.8 when I round. Okay, you can try that and see if you get that yourself. Centimeters squared because it's area. All right. That is how we would do area of a circle sector. That might be kind of new, something we haven't done before, but again, you're using the information they give you, plugging it into a formula. If you need to look at that a little bit longer, you can pause it. I'm going to clear these drawings so that I can scroll down. Okay, this one, this is a kite, all right? Area of a kite is down here, it's number 3. Area is D1 times D2 divided by 2. The D1 and D2 are just the diagonals, and they're the full diagonal, okay? And we just have to multiply them together, divide by 2. So one diagonal would be this one right here, the whole length. The other one would be this one right here, okay? And I know that this up here is 5. This one is going to be the same length, so this would also be 5. Okay, so area equals D1 times D2, and then all of that divided by 2. So diagonal 1, we'll do the red one. Okay, 6 plus 12 is 18. So 18 times the other diagonal, diagonal 2, 5 plus 5 would be 10. Now I have to do that whole thing divided by 2. So make sure you do 18 times 10 first. You can put it in parentheses. 18 times 10 we know is 180. Divided by 2, we get our area equals 90. Now they don't give us units on this one. If they don't, you can just put units squared since they didn't specify what kind it is. All right, that is a kite. And lastly, oops, I better clear that. Lastly, our shape that we are doing is a rhombus. So I'm going to move this. Okay, area of a rhombus is right here. This is super similar. It's the same formula as a kite. Okay, we take diagonal 1 times diagonal 2. On here, they have it multiplied times 1/2. But we know that multiplying by 1/2 and dividing by 2 are the same exact things. Okay, so it is the same formula. Area equals diagonal 1 times diagonal 2, and then either multiplied by 1/2 or the whole thing divided by 2. So let's take a look at this one. Now, with a rhombus, okay, so this length right here is 3. Okay, they tell us that's 3. That means that this length down here is also 3. All right, now this length right here is 4. That means this length right here is also 4. All right, so now we need the whole length of some of those. So diagonal 1, 3 plus 3 would be 6. I'm going to put that in parentheses. And then 4 plus 4, that diagonal would be 8. So 6 times 8 divided by 2. 6 times 8, 48, divided by 2, 24. So my area is 24 centimeters squared. All right, so those are the 4 different area of shapes we're doing today. Again, nothing crazy. You are just taking the problems I'm going to give you, use those formulas. I'd probably write them down or something, and so then you are doing those problems. I think there's 10, and then turn them into me. Thanks.